I'm looking forward to talk about trust, isolation, and reproducibility for agentic AI. My name is Gottfried Zeringer. I'm the CMO at lakeFS, and I'd like to welcome you to today's webinar. And I'm excited to be here, joined by Oz Katz, CTO and co-founder of lakeFS, who's been working this field for a long time and is an expert about this topic that we'll talk about today. So let's look, before we get started, let's get to some basic housekeeping items first. First of all, you can ask questions about the topic, about the webinar, throughout the webinar by using the question function within Zoom. We'll look at those questions throughout the webinar, and we'll address them in a Q&A session at the end of the prepared part of the webinar. One of the most popular questions we always get is, will we get a recording of the webinar? And yes, we will email a link to the recording of the webinar afterwards. You should get that within the next 24 hours from us. Now, what we have in store today, we have a very timely topic about agentic workloads in the enterprise. And what you've probably all seen, experienced firsthand, and reason why you're here is that the agentic workloads have really widened the data infrastructure gap overall across organizations. And we'll talk a little bit about what breaks when agents become this new class of data consumers all together. And then Oz will have some really strong recommendations in terms of what key pillars you need to put in place for a trusted foundation for agentic AI. And then we'll look at the live demo, how that actually can look like and feel like, and how you can implement that in enterprise in reality. And then we'll take some time for Q&A at the end. So please don't be shy and add your questions along the way. Now, before we get started, just a very quick intro in terms of context, what lakeFS is. You may or may not be familiar with lakeFS altogether. The best way to think about lakeFS is as a control plane for AI-ready data. lakeFS really sits between the data storage and the tools and the agents and the people that consume that data. It does not replace any of the existing tools. It just adds to the infrastructure, and it really handles those massive data sets and massive amounts of data of unstructured structure and metadata that exists across all your different backend systems. And of course, is now sort of a major source for agentic workloads. It acts as that for the frictionless data access for your tools, for your people, and of course the agents that we'll talk about today. But lakeFS is used sort of for all types of use cases across the enterprise. It's designed to automate data governance, auditability, reproducibility. That is really the cornerstone of today's enterprise AI that is required. And for the agentic use case, we'll talk about that. One of the sort of secret sauces behind the scenes that sits at the heart of this is our highly scalable zero copy data version control engine. You'll see that's sort of the secret star here, as you will see throughout the demo. Now, let's talk about that data infrastructure gap. And that's actually pretty crazy. There's a survey from Dun & Bradstreet that was just done very recently. They surveyed 10,000 businesses across 32 countries, so a pretty massive survey. And the good news there is, or maybe the unsurprising news is, that most organizations, in that case, 97% of all organizations, have active AI initiatives. But the scary part is that only 5% of those with initiatives say that their data is ready for those AI initiatives. And that's a crazy low number. And that's in a way what we also see here and what we are talking about here today. And Oz is talking to companies like this every day. And it seems like ensuring that that data is ready for an AI initiatives is often overlooked. So with agents on arriving on the scene, this is probably definitely getting exponentially worse. And Oz, I'm just kind of curious to get us going here. If you can take us through some of the key reasons that you see behind that.
Sure. Thank you, Gottfried, for the introduction, and good to have everyone joining in. So let's talk a little bit about the challenges, right? So I tried to create kind of a picture of this is the data landscape. This is what we had to deal with a long, long time ago, right? I'm talking 8 months back, before agents were becoming so popular. We basically had two main types of systems, humans talking to the data. And we had pipelines, mostly written by humans, and the humans themselves, right, doing ad hoc analysis, creating reports, using dashboards, trying to figure out how to best utilize the data. And they shared some of the traits in which both were relatively predictable, right? Pipelines are code, so hopefully when you run it multiple times, you're going to expect relatively similar results. And humans are also, I said kind of predictable, but at least in the workplace, we tend to be because we get paid for it. And same goes for accountability, right? As humans, as employees, I'm hoping we are accountable. If not, maybe time to look in and take a deep breath. Pipelines are definitely accountable, right? They're managed in source control. They're versioned. I can look at the specific pipeline. I know exactly when it was modified, who modified it. I have all this information available to me. Pipelines are also fast. Humans, not so much. We'll talk about agents in a second, but they definitely kind of flip the script on a lot of it, right? So they're not predictable, right? I might ask the same agent the same question 1 second after the next, and I might get completely different results, right? It doesn't have necessarily to be the same. In many cases, it's even kind of by design, right? That's the way LLMs are designed to do. They're very much not accountable in the sense that if they make mistakes, they might even try to cover up those mistakes. Not because they have a conscience, just because they want the human operating them to be happy and get what they want. So it's very, very hard to kind of trace back and understand what an agent modified, how it modified things. We don't have that same provenance that we had for pipelines. And what makes this even worse is that they're kind of fast, right? They'll give them the keys to production and they'll be all over your production, sometimes with good outcomes, sometimes not so much. So these three combined makes it very, very hard. Gottfried showed that image, that pie chart a second ago. It's very, very hard to take your existing data landscape and just hand it over to agents because the cost of mistake might be very, very big. And we don't really have any of the tools or the systems around it to protect us. And that's kind of the theme that I wanted to discuss today, right? What does it take to get our existing data landscape and hand it over to agents? What do we need in place in order to do that? So with that, we try to kind of narrow down into like, here are 4 things that if your AI stack provides, we can feel much safer in doing that. And I thought maybe a good way to showcase this is to demo it live, like take each one of those pillars, discuss why it's important, and also show it in practice. So I'll start with the first one on the left, which is isolation, which is a key component here. It's one of the most important pieces to this puzzle. So we talked about pipelines before, and we talked about the code itself. So anyone who's been writing software for the last 20, 30 years, it kind of goes without saying that if you're writing a line of code, you're doing it as part of a version control system. And the reason is you don't want to work directly on production code. You create a branch, you modify things in that isolated branch, and only when you're happy with whatever change you introduced, you merge it into production, right? We have this separation. For working with data, we don't typically have this separation. And that makes it, that cost of mistake I spoke about, that what makes it so tricky. Right? We give something direct access. If that thing screws up, if that agent deletes a file that it was not supposed to delete, we're playing with live ammunition, if you will, right? That thing is very hard to undo or to reverse. So let's look at isolation in practice. So let me jump right into lakeFS. So this is the lakeFS UI. As you can see here, I have a repository called product research, whatever name makes sense to you. And inside that, I have a directory called datasets, all kinds of different datasets. This is kind of meant to mimic what an organizational data lake might look like. So if I look at this datasets folder, let's do a size calculation. This is roughly 5 terabytes, not too big, not too small. With lakeFS, just like any other object store-backed system, this could be in the petabytes. Right? But this is here just to mimic a data environment. So this is my main branch, right? Just like in Git, I have this notion of branches. And for isolation, I want to be able to use those branches to run not directly on main, on my production data, but on my own kind of isolated copy. So the first thing I'll do is I'll create a branch for my agent. Let's call my branch agent1, derived from main. I click create, and as you can see, it took a couple of milliseconds to create. And those of you with an eye for detail might also notice that this points to a commit ID that is currently identical to the one on main. Right, Gottfried mentioned this earlier. Everything in lakeFS is built on top of that versioning capability, which is zero copy. Right, we haven't really copied everything to the agent1 branch, but this branch keeps track of the changes that we make and isolates them from any other branch. So on agent1, we have all the same data at our disposal, right? All those 5 point something terabytes, but they're isolated to us. So anything that happens on this branch stays on this branch until we say otherwise. So it's nice that we can create this through the web UI of lakeFS, but ideally we want to hand it over to an agent to actually do something autonomous with it, right? That's the ballgame. So to do it, there's many ways to consume and use data inside lakeFS. One of the easiest ways for agents to do so is to interact with that repository as if it's just a local directory on the machine it's running on. So for that, I'll use the mount capability as part of lakeFS. And I'll mount this agent1 branch into a local directory. And as you can see, that too took about a few milliseconds. And if I look at the data folder, it looks and behaves as if all the data is now currently residing on my machine, right? I can spin up Claude and tell it to investigate the data, to look at it, to do something interesting with it. And it doesn't really have to know anything about lakeFS in order to do so. But the nice thing is, because this is backed by lakeFS and lakeFS is lazily feeding that data in as the agent is consuming it, it's both very efficient and performant, but also completely isolated. Right, so let's pretend we're an agent for a second, and let's delete some data just to create some noise. I'll go to Spotify. There's a bunch of data here. Let's remove it. Also remove those part files. And let's say me, the agent, I'm happy with the changes I've made. So see the diff. Let's see what actually changed. I can see I removed a bunch of files. I'll do a commit. And now those changes are also reflected back on my server. So if I go to the commit log on agent1, I can see that commit. I can see all the changes that were applied as part of it, right? These are the deletions that we just made. But if I look at our main branch, and I go to the Spotify folder, there it is. All that data is still there. Here's the Parquet files. Here's the CSV that we had. These are all unmodified, right? And that's the isolation we were talking about. Now, if you combine this with a core capability of lakeFS, which is branch protection, right? Main is protected. That means that even if agents manage to somehow get hold of an API key that has access to main, you can't directly write to main. You can only branch out, modify things on that isolated branch, and then you have to merge them back. Right? We talked about accountability. There's no way to cover this up. So anything that happens on the branch stays on that branch. So that's kind of tenant number one, right? We got that isolation that we wanted. We have this piece in place. And if you look at it, because we had to commit our changes for them to be reflected, we also got that reproducibility piece. So let's for a second examine why this is important, right? So we said before, one of the problems with agents is that lack of accountability, right? For pipelines, if they screw up, I can look at the code, I can understand where the bug is coming from, I can fix it, prevent it from happening again. But if I have agents that are working directly with my production data, it's much harder to do, especially if they don't necessarily tell you that they did something that's destructive. So how can we still achieve that reproducibility? So if I go back to my lakeFS UI and I examine the commit log for the agent one branch, so first of all, I can see that I have this modification, right? Not just the data that was modified, which is of course an important part, but also who is the committer, right? Who made a change? When was that change introduced? What this change actually means, right? Here I just gave a pretty silly message, right? But ideally I'm going to give, just like in Git, a meaningful commit message explaining my change and any other metadata that might be relevant, right? I might want to put here which agent I was using, maybe a link to GitHub with the prompts that were fed into it. And maybe other provenance related metadata, like what version of the LLM model I was using, right? Is this Opus 4.8 or Haiku? Anything that might help me later understand why that change was introduced, I can add it as metadata to that commit. Now, the nice thing is I don't have to traverse this log to understand why things changed. And if I go to the data and I know that I'm unhappy with the state of that Spotify directory, let's switch to agent one. For any path, for any directory, or even a single file, just like I have git blame, I also have lakeFS blame. And so I can see exactly, here's the commit that last modified that path. Here's who modified it, right? I now have that reproducibility in place. I can go to that commit ID and get a snapshot of everything exactly on that commit as it happened. I can even go further and tag that commit, create a named version saying this is the data at that point in time. Right? Maybe I created a report. My agent created a report for the CEO with some business metrics. Here's the exact snapshot of the data that was used to create that report. Right? I have this kind of baked in because we have that versioning capability. So that would be tenant number two, right? The ability to reproduce results to give an exact immutable snapshot of the data. The next, let's say, very important pillar that we want to have in place is governance and compliance, right? Especially now that it's not just internal governance and compliance that we should care about. In many cases, it's also external compliance, right? Maybe we are working on scientific research and need to meet FDA approvals. Or maybe we are in the EU, or the EU AI Act is now being put into place, right? We have to kind of show how data is moving from one step to the other. And we also want to have controls in place to make sure that nothing that's forbidden or outside the compliance policy can actually happen. So we saw the commit log. That's, of course, a big part of that. There's a few more key elements that we might want to examine. The first is not just modifications, right? Commit log shows us how the data changed over time. We also want to see access, right? So if someone had an agent that was reading very sensitive data for no reason, we want to be able to trace that back and understand what happened and when. So just like we have our own data managed inside lakeFS, we also have some system metadata that's being managed inside it. So if I go here, I have an audit log that's kind of built into lakeFS. Let me spin that up. And it's available as an Apache Iceberg table. So here I'm just using DuckDB locally in order to query it. So this might take a second. But that audit log, which is part of lakeFS system catalog, gives us a full scope, full understanding of anything that was modified within lakeFS, not even just modified, but was accessed through lakeFS, with very, very fine granularity, right? So here I'm asking, show me anything that was looking at this repository, and it happened today, and it was done by this specific user, right? But I can decide to massage that query in any way I want to understand any access pattern, who was accessing sensitive data, who has access to what repository. I can figure all of this out based on that audit log. So if you combine that with that capability we saw before of that commit log, this is a very strong combination. All right, so here I'm looking at the Oz agent access log for today. So I can see that I was deleting a few objects, and I did a diff, and I did a commit, and I merged and created other branches and did a whole bunch of other things. And the system gives me all this information, and this is just standard Iceberg. So I can take this not just in DuckDB, but plug it into my dashboarding, into my alerting systems. I can design triggers around it to say anyone who touched /secret or /PII, maybe flag that or maybe examine what they were doing. And this is all baked into lakeFS, right? It's all part of that system. So that's one aspect of providing governance, which is just being able to get that visibility. The other one is prevention, right? How do I prevent the agent from doing something they're not supposed to do? And for that, lakeFS provides two kind of core capabilities. The first one, which is kind of table stakes now, is role-based access control at a very granular level. So I can define specific policies, assign them to groups, assign users to those groups that say exactly what an agent can or cannot do. Right? So maybe I have some secure or highly regulated repositories that I want to very much limit the access to, while public data any agent can examine, but only specific agents can write to. And I can define this using like this very granular language that says exactly what specific repository or objects within a repository you're allowed to use, who can commit, who can roll back, who can do any of those actions. So that's one aspect of it. But sometimes we need something that's a bit more domain specific. And for that, lakeFS has a notion of hooks, just like in Git or GitHub. So I can say, okay, main is protected, right? This is a protected branch, but any branch called agent something has to go through this pre-merge hook in order to push anything into main, right? So I deleted some stuff from that Spotify directory, but maybe in production, I want to make sure that on main, no changes are ever applied to that directory unless it's also documented somewhere. Or maybe I want to say you can't introduce new columns that have an email inside them because that's potentially PII and it's dangerous. Whatever makes sense to our business rules or business landscape, we can define it as a pre-merge hook and prevent those changes from ever being applied to main. Right, so we achieve governance not just by providing that visibility, but also controlling what can actually be modified. And that takes us to the last aspect. So how do we make the data not just safe for consumption by agents, but also accessible for them? And we saw that capability of mounting before, which is very nice when you work with unstructured data. We want to examine images, work with text files, convert PDFs to summaries, all things that agents do pretty well nowadays. But in some cases, we also want to work with structured data, where accessing a single file doesn't necessarily make sense. So with this, another core capability of lakeFS is being able to version not just files and folders, but actually tables and namespaces. And this is because lakeFS itself has an Iceberg catalog baked into it. So let's see that in practice. So I have this structured data demo. So let's take a look at that. Right, so we saw that audit log from before, but what I want to focus on now, so I'll give the agent one branch, is the ability to examine data as a tabular formats, not just the unstructured ones. So looking at the lakeFS UI, if I go back to the product research repository, I see that I have that objects tab that we were looking at, but I also have a tables tab, which shows us the Iceberg REST catalog interface. And inside that repository, switch to my agent branch, I have 3 tables, comments, submissions, and Spotify tracks. So again, I'm using DuckDB here, but any Iceberg client can do this. Let's examine this Spotify tracks table, and I can see that I have a bunch of tracks, and they have all kinds of metrics attached to them, as well as a genre. So let's say my agent is unhappy with those and he wants to make a modification. And let's say I want to delete from that table anything that the genre is emo. My agent does not like emo music. So I'll run that, and I see that it actually modified some data on my branch. Right, so going back here, I can see that now this table has been modified. And just like before, if I want to introduce that change to everyone, I have to commit and merge those changes. So let's do that for a second. Removed emo songs. I can commit this on my branch. And now let's say, again, because of the governance rules within my organization, I don't want the agent to have autonomy to also push this into main. I want a human in the loop to review those changes. So I can go to the pull request tab and actually instruct my agent to create a new pull request. So trying to merge agent 1 into main. And these would be the changes, right? We modified, removed a bunch of data files, but we also modified the Spotify tracks Iceberg table. And this would be my pull request, and now a human has to approve it, which again, I can enforce this for happening using those pre-merge hooks, right? Anything that has to go into this repository, sorry about that, must go through one of those checks in place. So that's kind of, in a nutshell, the different ways of accessing. One other nice thing is, because this is all based on industry standards and tools that pretty much any system can interact with, right? Whether it's a POSIX file system or the Iceberg catalog, I can also use MCP servers. For example, here I'm using the DuckDB MCP server to actually have an agent interact live with that system. So I have this MCP file that I created. It's using a DuckDB extension called DuckDB MCP. It loads the lakeFS catalog and starts that MCP server. And this allows me to do stuff like ask Claude what different genres exist inside the Spotify tracks, right? That table we just saw. It examined the table and came up with the list of unique genres that exist within that table. Unfortunately, emo was still there at the time. So that means that in terms of accessibility, there's multiple different ways for agents to now interact with our data, whether it's structured or unstructured, right? Or a combination of multiple modalities. And the thing is, we really have to have all 4 in place in order for agents to actually interact safely and efficiently with our data. Reproducibility without isolation means everyone's working with noise and stepping on each other's toes, right? Especially if you have multiple swarms of agents running at a time. And doing anything without governance means we're kind of taking a huge risk without having the right controls in place. So it really takes all 4 pieces of this puzzle to solve the problem. Yeah, I ran through this quickly. So I think this might be a good time to, Gottfried, maybe open this up for questions if we have
Yeah,
them.
thank you. So, and while I'll look at questions coming in, please again feel free to just use the question box below to add some questions. Just to maybe just jump back to your prior slide for 1 second, because there was a lot in there. And I think the first question sort of goes already in that direction. So the isolation really it's sort of the question goes a little bit along the lines of, do I understand that as my sandbox where I can provide sort of the data for my agent with all the guardrails around it that you, of course, and talked about with reproducibility and compliance. Is that sort of a good way of thinking about it?
Yeah, for sure. I mean, there's been a lot of talk about sandboxing for agents and using micro VMs and all kinds of different technologies that now are being put into place to solve isolation at the compute layer. But there haven't really been a lot of solutions on solving this for the data layer. And one could argue that even if you have a very strong virtualization solution to kind of run that agent on a secure computer, if that computer now has access to your production data, then that sandbox really didn't do much for you, right? So you kind of have to solve both.
Yes, yeah. And how does that interact with sort of the other sandboxes that we've seen that are more focused on compute, like an E2B or Daytona or something like that?
Yeah, so this is kind of the combination of the first and fourth pillar, right? Isolation is great, but it also needs to be accessible. So one of the things we really invested into with lakeFS is that mounting capability, right? So you can spin up a VM, a micro VM on E2B. Now you have your compute sandbox or Daytona or any other tool you're using. Run that mount command within that sandbox, and now you get that combination of both. Right? As far as the agent is concerned, they're running on their own isolated sandbox environment with access to sandboxed data that's now being connected into that compute.
Yes, yeah. Now, of course, it all sounds sort of simple and straightforward to talk about one sandbox and one agent and sort of one process here, one workflow, etc. But obviously, we talk to a lot of companies, are massive companies, some of the world's largest companies altogether. You already mentioned petabytes of data that we see a lot. So how do we have to imagine this for lots and lots of agents that potentially interact on the same data or parts of the same data, and interact with massive amounts of data, not just sort of my little quote unquote sandbox, but the entire Spotify, for example.
Yeah, that's a great question. So, like for the sake of a demo, I showed a repository with 5 terabytes. But the idea behind lakeFS is how do we take this approach and scale it to actual real data lake sizes, right? You mentioned petabytes. We have lakeFS users and customers that I know of that have hundreds of petabytes. So there were kind of 2 core tenets behind the design of lakeFS that should make this possible, right? First one is like the scale of the object namespace itself, right? How do I scale to billions of objects and those massive, large quantities of data? But also, how do I design branching to be very, very cheap and efficient? And I think the most I've seen is a workflow that ends up creating 9 million different branches as part of its run, and then collapsing and merging all of them back together at the end of it. So we have customers doing pretty crazy things with that capability. But the idea is to make that scale, right? Otherwise, just use Git and put your data there. But we all know that's not going to end well. And that's kind of one of the main things behind lakeFS's design is to exactly support that kind of use case.
Perfect. Now, what does it take to implement this? How do I have to sort of think about this in my existing tool stack? And yeah, what's the effort? Do I have to change anything in my existing data infrastructure?
Yeah, so obviously you need lakeFS, right? So that's one change you have to make. But the idea is, and again, this is kind of part of the philosophy here, is that just like Git is pretty much transparent, right? You're not using a specific flavor of Git to do React and something else to do, I don't know, backend with Java. We're all using that same tool and it kind of disappears into the background until you need it. So lakeFS is mostly designed to work that same way. So your data stays in place. You spin up lakeFS. That takes about 40 seconds to do. And you can import your existing data, right? And data stays in place, and you create a repository out of it. And once you have that, you can start branching, you can start merging back. Obviously, all the version data is stored with lakeFS, but any of your existing data, right, especially if you have petabytes of data, these just stay where they are, right? You don't need to move them into the system in order for this to work.
Perfect. Perfect. Here's a question. I suspect it's probably from one of our existing customers and users who've been using lakeFS for model development, sort of the whole process of AI modeling. And the question is, do I have to do anything differently? Is this different instance of lakeFS, or how do I keep sort of model training, agent activity, and maybe even access from users who might just want to get sort of manual access to data? How do I keep that separate, or is it all part of the same thing?
So at the infrastructure level, it is and should be the same system, right? If you already have lakeFS in place to do model training or pre-training, you can keep using that same lakeFS infrastructure that you already have to do all the stuff I just showed, and of course, much more than that. So it's the same core capabilities. One thing I would say is because of that governance and compliance angle, you probably want to think about designing the right guardrails for agents, right? Because what worked for your existing pipelines that end up producing a model might behave very differently from agents just running loose on your data lake. So scope them out, give them the proper permissions, and put those right access controls, but also those pre-merge hooks we talked about to make sure that they're actually working in an environment you can trust, right? What they can and cannot do. But it is and should be that same infrastructure, the same component.
Yes, that's indeed really the beauty of this. And if you organize the right way, it works really well. Perfect. I think I'm just looking here. There doesn't look like there are any more questions at this point. So with that, I thank everybody for joining today's call. And Oz, if you flip to the last slide, there are just a couple of links here. If you're interested to see this sort of more in action, maybe with your particular environment or with your particular requirements, feel free to go to the lakeFS website and hit the demo button, lakefs.io/demo, or you can get started right away and sign up for a free trial at lakefs.io/try. And with that, thank you very much for joining today, and we'll hopefully see you soon in the LakeFS world.